So now what we have is we have this gradient descent curve, right? We have a descent curve by plotting these points, which is called a gradient descent curve, right? We have this gradient descent curve. Now the point which is showing here is the best fit line, and which is also called a global minima. And with the help of this cost function, we can reach with the help of this cost function we can reach the global minima at this point. Suppose if we don't know where to start actually. Suppose we have started with some point here. Now we wanted to reach to this point, which is a global minima. How we can reach to that point? For that what we'll be using is we'll be using a convergence algorithm. Let me write here a convergence algorithm, right? A very important. Now what I would like to do here is I wanted to put the same graphs like earlier, which is a theta 1 and the cost function of j theta 1. So we have seen that our gradient descent curve will be something like this. Now we have some point here, right? We have some point here, and we want and if we wanted to find the slope of this point, it will be like this, and this will be a positive slope, right? This is a positive slope, and we will also have another one. We will also come across a negative slope also. Let me just write the same thing, same gradient curve. So we also have negative slope, so we also wanted to find something, kind of slope here, which is a negative here, right? So suppose if I have a point here, I wanted to reach till this point. For that, what I would like to do here is we have a formula which is called theta j. Theta j is equal to, I can just mention it like this, theta j minus alpha into partial derivative of theta j of theta naught comma theta 1. So I can write this equation right like this, because theta j is assigned to the theta j, because this is the value which we wanted to convergent from point to point. So that's why I'm writing this equation like this. Now what we would like to do here is, here the value, let me just say that here it is theta 1. I just wanted to write it theta 1, which is theta 1 minus alpha. Alpha is a learning rate. Learning rate means, suppose if we have a point here, we wanted to reach here. If alpha is quite less, which is about 0.05 most of the times, if it is lesser actually, it will take lot of time to learn this data to reach that minimal point. And even if it is high, what it is going to happen, it may come here next time it may come here, it may skip the minimum point here, and again it will go here, it will come here, it will come here again, it will skip here, it will come here. So if learning rate is high, these points will be jumping from point to point, so it will be difficult to find, to identify the global minimum point. So learning rate should be such a way that it should be uh, it should come to the global minimum point. So there we also need to use some set of algorithms. So for now, let's see this equation here. Okay, now minus alpha into, I just wanted to write here what kind of slope I have here. I have a positive slope, right? Now if there is a positive slope, if I have a point here, I have a positive slope, and I am deducting from theta 1 minus with some learning rate and positive value, right? If I use this equation, my value will be going from this point, this direction to this direction, right? And it reaches at some point to this value. Now, suppose if you get a negative value, suppose if you have a negative slope, suppose theta 1 will assign is equal to theta minus learning rate, which is a negative. Now, in this case, if your slope is negative, if you have a point here, if your slope is negative, now if if your slope is negative, you are when you wanted to move this point from here to here, it will be negative, right? And what it will do is it will try to come more and more near to this point so that it will reach to the minimum. Definitely these equations are going to help to find the global minimum point, so which is very very important actually. So here you can also see that, like, as I'm saying that global minima, uh, in an axis like x and y axis, you will find different local minima. Suppose you have an equation, you have something like this, right? You have some kind of curve like this. This is a global, this is a local minima. So every time you start with some point here, you may have some cases you will be falling into the local minimum. But with this, this is the global minimum because this is more down, right? Like, which is very very minimum actually. So this is called global minimum. So to reach this value, convergence theorem will help with respect to the cost function, right? So this is about the convergence actually. So how this convergence algorithm works actually, how this convergence, this is this will be repeating, this equation will be repeat convergence until convergence, right? Repeat until convergence. Convergence means where it will take the minimal value. So this is about a convergence algorithm. We'll discuss more in our next video.